Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we look at parabolas. So parabolas are just the graphs of quadratic equations. So earlier in the year we did the graph of linear equations. So now we're going to look at the graph of quadratic equations, and they have the same general shape to them. So remember, as we learned last time, a quadratic equation has an x squared term. So here, because we're graphing, we're looking at y equals something to do with an x squared term. That is a quadratic equation, and its graph will be a parabola. So let's look at this by graphing using a table of values. You can use table of values for any curve, anything you need to graph, but as we move on, we want to get better methods. But it's okay to start with. So remember, to do table of values, you draw up a table, you choose the x values, and you substitute in the equation to find the y values. So I'm just going to do from x equals minus 2 to 2. Okay, so if x is minus 2, y is minus 2 squared, not negative 4, that's positive 4. So whenever you square a negative number, you still get a positive answer. Negative 1 squared is 1. Make sure if you're putting it on your calculator, you put brackets around it like this. So if x is 0, y is 0 squared, which is 0. If x is, that should say positive 1, then y is positive 1 squared, which is 1. And if x is 2, y is 2 squared, which is 4. Okay, so that's a table of values. So let's draw up our Cartesian plane and plot these points. Okay, so make sure you've ruled up your Cartesian plane properly, like I have here, and we will plot the points. The first point is x is minus 2, y is positive 4. So you got to where they meet, and we plot the point there. Next point, x is negative 1, y is positive 1, 0, 0, 1, 1, and then 2, 4. So you can see this has kind of a weird shape. So if I join up the points, you can see that it's curved, it's not a straight line, and it kind of comes down and then goes back up. And that's what all parabolas do, and I should label this y equals x squared. Okay, they all follow this general shape of a U. Sometimes it's upside down like that. So all parabolas have a few features. So they always have a y-intercept. So here the y-intercept is 0. They always go through the y-axis. So they always have a line here that is the axis of symmetry. So we call that the axis of symmetry because parabolas are actually symmetrical. So that is the line in the middle of it. It's almost like this line, this dashed blue line, is a mirror. And on this side of the graph is a mirror image of this side of the graph. Now the axis of symmetry also goes through the turning point. So this here, not only is it the y-intercept, it's the turning point. Every parabola has a turning point. It's either a minimum if it's down the bottom of the parabola, or it's a maximum if it's at the top of a parabola. So this parabola has a minimum turning point, and the axis of symmetry always goes through the minimum turning point. So this one also has an x-intercept. Not every parabola has an x-intercept. Some parabolas have 2, some have 1, some have none. This has one x-intercept. So these are the features of the parabola. So as I said, it's always the same general shape. It's like a U shape. Sometimes it's upside down. It can be thinner, it can be fatter, it can be moved across left to right, it can be moved up or down. But they have the same general shape. They always have a y-intercept, always have a turning point and an axis of symmetry. Sometimes they have x-intercepts. All right, let's go ahead and look at another example of a parabola. So I'm going to go ahead and graph y equals x squared minus 4, for example. So I can use a table of values again. So I draw up my table. I choose my x values and my y values. So this time, to get a bit more information, I'm going to go from minus 3 to positive 3. So again, I'm choosing the x values. So I choose them and substitute each into the equation. So if x is minus 3, y is minus 3 squared, which is positive 9 minus 4. X is minus 2, y is minus 2 squared, which is positive 4 minus 4. If x is minus 1, x squared minus 4 is 1 minus 4, which is minus 3, and then 0 minus 4. And then we have the same here because negative 2 squared and positive 2 squared are the same. Negative 3 squared and positive 3 squared are the same. So notice what's happening here is each time the x value is increasing by 1, the y value does different things. It went down by 5, then it went down by 3, down by 1, then it started going up. So that's why it's not linear. Different things are happening each time you increase x by 1. So let's go ahead and graph this. Again, I'll pause and draw up my Cartesian plane. Okay, so I've got my Cartesian plane drawn up, and all I need to do now is plot the points in my table. So I start x is minus 3, y is positive 5, so that's up there. Then minus 2, 0 is there. Minus 1, 3, so I go x is minus 1, minus 3, 0 minus 4, and then again there's some symmetry here. So 1 minus 3, 2, 0, and 3, 5 is up there. I'm just going to join up these points, easy as you like. Again, it's a nice curved shape. And we can see there's a turning point as well. So that's my graph of y equals x squared minus 4. So if I'm asked a few questions, so the turning point here occurs at 0 minus 4. So that's the turning point. The axis of symmetry is this line here. So hopefully you remember perfectly vertical lines have the equation x equals something. So in this case, the x coordinate is 0. So that is the axis of symmetry at x equals 0. So here, the y-intercept is the same as the turning point. That won't always be the case. So it says 0 minus 4 is the y-intercept. And the x-intercepts here, there are two x-intercepts. So there's minus 2, 0 and 2, 0. Okay? How easy is that? So I just want you to get comfortable identifying the features, because in a subsequent lesson, we're going to use these features to graph any parabola without using a table of values. Alright, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Thanks for watching.